We can affect the rate of a chemical reaction in several different ways. And one way to affect the rate of a reaction is by simply choosing reactants that are more reactive. And that seems intuitive, but when you're looking at something like calcium and sodium, now they both react with water, they form hydrogen gas and a base, but calcium reacts much more slowly than sodium. Sodium is a much more reactive metal. So if you were looking to make as much hydrogen gas as possible, and you were given a choice between calcium and sodium, you would choose the sodium. Although they both form hydrogen gas, sodium forms it much faster. Now, if you would like a more controllable reaction, one that, say, doesn't explode your sink, then you would choose the calcium instead. Now, we can also affect the rate of a reaction, and this is going to be due to particle size. So if you have like a big piece of iron, it will eventually rust. But if you have iron filings, it will seem to rust much faster because there's more surface area for the reaction to occur. So that surface area is a way that we can affect a reaction rate. We can also affect the rate of a reaction based on temperature. Chemical reactions usually occur faster at higher temperatures. Now that's usually, not all the time. And a lot of times, an increase in temperature of only 10 degrees Celsius will generally double the rate of a reaction. And this is for a homogeneous system. Again, that's just a rule of thumb. It's not the case for everything. We can also affect the rate of a reaction due to the concentration of the reactants. If we have more reactants, we have more collisions. If we have more collisions, we have more reaction. And we are producing more product. So we can increase the concentration of our reactants in order to increase the reaction rate for most reactions. Again, if the reaction is not dependent on one particular reactant and you've raised the concentration of that, you're not going to see a change in the reaction rate. And we're going to see that on the next page. Now, when we insert a catalyst into the system, a catalyst decreases our activation energy. We covered activation energy on the first page. So if we add a catalyst, we can increase the rate of the reaction by decreasing the activation energy.